welcome back everyone. My name is Dustin. This is going to be the first video of the new year, so I'm pretty excited. In the past few videos, we've been working on the renderer, and we've also been working on refactoring of how we are doing our batch rendering. So in this video, we're actually going to start getting into fonts and text rendering. So there's a few things that we're going to have to be able to do. First, we need to be able to create the font, so we're going to be creating a font class for that. In our font class, we're going to be using the STB true type for our implementation so we can use the baked quads. So we'll just be adding the STB true type to our soil project. That's the goal for that. So after we have the font created, we're going to want to create a font loader. We want to treat the fonts just like the textures and shaders. We don't want them to load themselves. We want to have a loader to do that. So we're going to create the font loader as well. Then after we create the font loader, we need to actually now add that capability to the asset manager so we can load the fonts into our assets. We basically want to do it the same way that we do our textures and sounds and stuff like that. Then after we can create and load fonts into the asset manager, we actually want to create the text batcher. And then we also want to add in to the renderer, we want to be able to render the text that we create, like the draw text functions that we create in the renderer are going to be basically just for debugging. We're not going to want to do it like that, but we will have a simple draw text function so we can draw text to the screen. All that type of rendering, like any of the functions that we have in the renderer, like draw sprite, draw circle, draw quad or rect, draw a line, those should all just be test functions. You don't really need to use those. You'll use systems for that, different like animation system, render text system. Those should be used instead, but we still want to have those test functions just so we can basically do testing. That's what we need. Then at the end, we need to bind it all to Lua. Now, that's a lot of stuff to go through, so we're probably not going to get through it all in this first video. We'll see what we can get done. So the first thing we're going to need to do is actually create the font class. So let's get into that now. All right, so this is where we left off. So we did the draw rect and draw a line. Now there's still the draw filled rect. Hopefully you guys figured out how to do that. And then we have draw circles, and I will get around showing you guys how to do that, but it's not as important right now. Really, we want to get into being able to do the fonts and being able to draw text to the screen. These ones we'll go over how to do these in the next couple of videos as well. All right, let's go down into our rendering and go to our essentials and create our first file, and it's going to be the font.h file. Font.h, cool. And for our fonts, we're going to need to have GLM. So include GLM. We're going to want to have glad. And we're going to want to have our vertex. So include vertex. Okay. Then it's our namespace. Scion rendering. Cool. And okay. So the first thing we actually need, we need to have a font glyph. So the font glyph needs to have a vertex for min and max. Okay, so let's do that now. So struct font glyph. And it needs to have a vertex for min and max. Cool. And then we're going to have our class for font. And private, public. Okay, so we're going to want to have a variable that's GLUINT, and that's going to be our font atlas. So M font atlas or ID, atlas ID. So it's basically just a texture ID. Okay, and the font is going to have a width, M width, and M height. Then we're going to have a float for font size, so M font size. And then we actually want a void pointer to the MP data. Okay. So we're using a void pointer to hold on to the data from the STB-TT baked font bitmap. All right, so we take a look at this here. So this is the STB true type header that we're going to be downloading shortly. I already have this on one of my other files, so I'm just showing it to you right now. So basically what it takes is, it takes in all this different data, and we're going to need to have this baked char. So this is going to be our baked char data. Now we could have a pointer to this, but we can just hold on to a void pointer and use a cast whenever we want to actually use it as a baked char. So also in our destructor, we're going to want to destroy the pointer because our font will be holding on to that data. So in our font destructor, that's when we'll release that data. Okay, so that's our member variables. Now we already have public here. So let's have our constructor. So that'll just be font GLUINT, and that will be our font ID or font atlas. ID. And then it'll be our width, int height, our font size, and then also our void pointer to our data. And then we'll actually have a destructor for this. Okay, so we're going to have a function that will return our font glyph. That's get glyph. That takes in a char, or the character that we want to return. And then it also takes in the glm vec2 reference position. Or we can just say pause. And we can have two functions. We can have inline const gluint get font atlas ID const. That'll just return the atlas. Font atlas ID. And we'll have inline const float get font size. Const return font size. Cool. Let's go quickly get STB TrueType and add it to our soil project. Okay. So we can go here to our soil project, to our includes soil. And right here, we can just add a new header, STB TrueType.h. All right. So now that we have that, let's go and grab it from GitHub. So you just go to STB, so nothing's STB blob. I'll leave the link in the description, STB TrueType. And we want to get the raw of this, STB TrueType.h. Just copy this all, go back into our file, paste it in. Awesome. Now we got it in there. Now we can just include this wherever we need it. Okay, so let's open up our font.cpp, go back into our rendering. Font.cpp. Let's fix this real fast. Take this. Cool. And let's just do our font atlas. It's font atlas. Font size, and then the last one is our MP data. Awesome. Okay. So our destructor, we want to check to see if the font atlas is not 0 and that the P data is not null pointer. If they are, we can delete them both. Okay. So if font atlas is not equal to 0, GL delete textures 1 font atlas ID. So we're deleting a texture because that's basically all a font is. It's a baked texture that we need, okay? And then we can delete the data. So let's just check to see if it's null pointer. So if we have data, delete the MP data. Cool. So the get glyph function is pretty straightforward. We're going to be using the stbtt get bake quad function. This will create the quad that we need to draw and advance it to the next position. So first thing we want to do here is just go font glyph. Let's actually just take this here. And that'll just be the new glyph. So we just say glyph, create one. Okay. So we're sending in a char or a character. So we want to see, if we take a look at this ASCII table here, we can see that our characters actually start at 32. So we want to have all of these because we'll probably have these in our TTF. So we need to have access to these. So from 32 to 127, so let's put a check in for that. We don't need anything before or anything after. So we want to check for both of those. So we want to check to see if C is greater than equal to 32 and C is less than 128, then do what we need to do. Other than that, we just return the empty glyph. So we'll be returning the glyph. Whoops. Okay, so this is where we do all the dirty work. So to use the function stb TT get baked quad, we're going to need a few things. So we're going to need, if we take a look at this here, we're going to need the baked char data. That's our data being sent in. And we actually have that as a void pointer. And then we need to have the pixel width. That's the width in pixels of the atlas itself, the width and height. Then the char index, that's the character that we want to find. And we need to subtract the first character from it, which is 32. Then we also have to send in the current X position and the current Y position. That's in pixel space. We also need to have a pointer to STB align quad. Now this is the actual quad that we want to draw to, so let's actually write that down now. But then we have also the OpenGL fill rule, and we'll be setting that to true. So first thing we need to do is create that quad. So STB TT aligned quad, and we'll just call this the quad. And we can send in our data. So remember, we have a void pointer, and it needs to be STB TT baked char. So we need to cast it. So we'll just do a simple C cast STB TT baked char pointer, and that's our MP data. Then we can send in our width. We can send in our height. Then we can send in our character index, which is going to be C minus 32. And then we can send in our position dot X and our position dot Y. Now these are pointers, so we need to send in the address. And then we can send in our new quad as well, which also needs the address. And just 1 for our OpenGL fill rule. That's basically setting it to true. All right, now that we have our font data, we can set our min and max vertices for our font glyph. So let's take a look at the STB aligned quad. Let's take a look at this. So we can see that we have a top left and a bottom right, and both consist 4 float values. The X's and the Y's are your actual pixel positions, and then you have your S's and your T's, and those are basically just the UV values of the font atlas texture. Okay, so right here, this is the OpenGL fill rule. So we set it to true if OpenGL fill rule, false if DX9 or earlier, other things of that nature. Okay, so let's go back. So remember, the X's are your position, the X and Y is your position, and your UVs are your S's and your T's. So let's do our min and max. So we go glyph dot min is equal to a new vertex, and then we have our position, which is equal to glm vec2, and we want to send in our quad dot x0. Oh, it's not happy because I'm outside of this. Sorry. Make sure you're inside the if statement. And quad dot y0. Cool. And then we also want to set our UVs, and that's going to be equal to glm vec2 quad dot s0 and quad dot t0. Awesome. So now we need to do the same thing for our max. So let's just change this to max, and these are all changed to 1s. 1, 1, 1, 1. Awesome. And then we're just returning the glyph. Cool. So now that we defined what a font is for our engine, we need to create the font loader so we can load the font into our engine. So let's go do that now. So we'll do it right here in our essentials, add, new, font loader.h. Okay, so we're going to need memory. String, and we're going to include our font. Well, we don't even need to include this. We can just use a for declaration. We want our font loader to follow the same concept that the texture and the shader loaders are, so we're going to do the same idea. So namespace, Scion rendering, and it's going to be class font loader. Everything's going to be public for now. And we're going to delete our constructor. So we're going to have two loading functions. We're going to have a create function and a create from memory. And they will both return a shared pointer to a font. Now the create from memory will take a const unsigned char pointer. This way we can have a default font and not worry about having to have a TTF file loaded. And then we'll have another one where we can actually load fonts. So static std shared pointer to a font, create fonts string reference. That's the font path. And then float font size. That's going to default to 32. The width. That's going to default to 512. The height. That's going to default to 512 as well. Now we can just copy this and change this a little bit to create from memory and change this to const unsigned char pointer font data. Cool. All right, let's create these two functions. Okay, so we're going to need a few things in here. We're going to need our font. Get rid of that. We're also going to need fstream. And we're going to need vector. We need our logger. And we also have to use stb true type. So we're going to actually have to define something here. Define stb true type implementation. We need soil. We need stb true type. All right, so to create the font, we're going to need to read the file into a buffer, and we'll be using std ifstream for that. So let's do that now. But first thing we want to do is check to see. So go std ifstream, and we'll say font stream is equal to font path, and then we want to load it as a binary. Okay, so then we just say if font stream failed, we want to have an error. Failed to load font. Unable to read buffer. Font path. Cool. And we'll just return null pointer. So we need to find the end of the buffer. So we need to use seekg to the end of the font stream. So font stream dot seekg, start from 0 and go to the end, font stream dot end. Not dot end, sorry. It's not a function. And then we want to go int 64t length is equal to font stream dot telg. That'll give us our length. Well, it actually gives us a stream pos, std stream pos, which basically is a length. Then we can go font stream dot seek g 0 font stream dot beginning. We want to set it back to the beginning. We don't want to keep it where it was. Cool. And then we need to create a buffer, and we'll just create a vector for that. std vector of unsigned char. That's going to be our buffer. And let's resize the buffer. Buffer dot resize by the length. Then we also need another vector for the bitmap. The bitmap is going to be the actual data used in GL text image, and it's also sent in to the STB/TT bake font bitmap. It will fill that bitmap with the necessary data. So we'll go std vector unsigned char. That's our bitmap. Then it's bitmap dot resize. We need to resize this by the width and the height. And now we want to read the stream into the buffer. We need to cast it to a char. Start at the beginning, and it's based on the length. Swore I hit push read there. Cool. So now that we've read everything into the buffer, we need to call stb/TT bake font bitmap. And this takes in our buffer data. So buffer.data. There's an offset, but we're not going to have an offset. Then we have our font size. So the pixel height is our font size. And it's a float. Then it has our pixels, and that's going to be our bitmap data. So it takes in a pointer to the pixels. It's going to read the data into that bitmap. And then we need our width. Then we need our height. Then we need the first char, and it's going to be 32. Number of chars, there's 96. And then we have our STB/TT bake char data. So we need to cast this. That's our void pointer. Speaking of which, we didn't create that. So let's create that now. We go auto data is equal to void pointer new STB/TT bake char. Make it 96 for the size. Now, we don't want to delete this data because it's going into our font that we're going to hold on to, that we're sending back. We'll delete it when the font is deleted. So we need to cast this STB/TT bake char pointer. And that's our data. Cool. All right, so now we can generate our texture. So let's go GL UN, because that's basically all it is a texture, and we're going to need an ID. So let's go font ID. And we can go GL, then textures, one at font ID. Okay. So now we have to generate our text image. So go GL text image 2D, and it's GL texture 2D 0 GL red width height 0 GL red GL unsigned white. Not uniform, my bad. And then we need to send in our bitmap data. All right, so I use GL red here for a reason. We're storing the values for the font glyphs where red, green, blue, these colors are actually all 0. The glyph mask will be completely contained inside the alpha channel when we do it in the shader. So for this, we're actually going to use GL red as the internal format. The font glyphs are represented by a single byte. So GL red will be the actual mask that we're using. This will make more sense when we actually look inside the shader. Then we also want to generate our bitmaps. So GL generate, not GLM, so GL generate bitmap, GL texture 2D. Now we need to set our text parameters. GL text parameter I. GL texture 2D. GL texture wrap S. GL clamp to edge. And we can do the same for T. Then we need to set our min filter and max filter or mag filter. GL texture min filter, and that's just going to be GL linear and mag filter. Now you can set this to nearest as well, and it does work as well, but we'll just use linear. And now we can actually create our shared pointer. So let's go std make shared. That's our font. That'll take in our font ID. That takes in our width. That takes in our height. That takes in our font size. And it also takes in that data that we had. Okay. So right now, we'll wait for later for the font from memory. It doesn't really matter, but I'll leave this to you guys to figure out after we get it to work. And let's just run this. Let's take it out of release. Just put it in debug. Let's just run this to see if it actually builds and fix any errors that we have. So let's run it. Awesome. So this is what we had from the last video that we made here. So it built and everything looks like it's working. However, we don't actually know if this is working yet because we're not using it. But that's enough for this video. So I do have a small challenge for you. The challenge would be to add this font loader to the asset manager. So if you come here and we go up to our asset manager, core, resources, asset manager, we basically want to do the same thing that we're doing with add texture. We need to add in our fonts as a map and a shared pointer. Go to add texture, and you see how we're using the texture loader, create, blah, blah, blah. We're going to want to be able to do the same thing using the font loader. So that's a little challenge for you guys. So why don't you try that challenge, try to add the new font loader to the asset manager and see if you can get a font loaded. If you can do that, that's great. If not, it's no worries. I'm going to go over that in the next video. And then in the next video, we're also going to get the text batch renderer working. All right, so that's it for this video. If you have any questions or concerns, please leave a comment below. Also, if you like the video, please like it and subscribe if you haven't already. All right, take it easy.